Good afternoon. Let's see, do we have the slide? Okay, so I'm going to talk about something which is not strictly part of 911 or NG911, but complements it very nicely. And several people during the day so far have said that there is no one single solution which is going to solve all the problems. We need complementary solutions. We need to use technology in ways that are at least as imaginative as our adversaries. Before I start, I've got a question. How many people recently have been at an airport? How many times when you were at an airport did you hear an announcement that you should keep your bags with you, you should make sure that you never give your bags to anyone else, and that you should call emergency services if you see anything unusual? How many times did you see it? How many people actually listened to any of it? The point is that 911 is fantastic. It's an essential way of making sure that people who see things have a way of reporting it. But sometimes they get desensitized, they get distracted. And so what I'm going to talk about today is some technology which complements that by allowing us to use machine vision as an alternative to human beings observing things. So let's go to the next slide. And I want to show you a video. This may play a little oddly, but yeah, there's a little bit of breakage at the beginning here. It'll clean up, don't worry. Or it did anyway in our test. There we are. So this is a perfectly ordinary situation at a train station. And people getting on the train, nobody's paying much attention to anyone. And there's some people with packages in the background, but nobody's paying much attention to them. And the train pulls out. And this guy walks across the track and just puts that package in the bushes. Now, and he comes back here. He's now back in a normal safe zone, and we would normally we'd lose track of him. But if you see in the top right-hand corner there, we're still watching that package because we know that that package isn't supposed to be there, right? This is something which the scenario is fairly clear. The analogies are fairly clear. We all know about the Boston bombing. This is the kind of thing where ideally a human being sees this and reports it. But sometimes they won't, and sometimes we need alternative technologies to do this. Let's go on to the next slide. Oh, I'm sorry, I got my button now. So I'll skip over some of the sort of the marketing stuff. At Verizon, I am the Chief Technology Officer for Smart Communities and Venues, and that in itself is an interesting job title which nobody would have understood 10 years ago, or 15 years ago. And what we're trying to do is to create an IoT platform for all kinds of smart city, smart community, venue, airport, stadium, campus functions. And we tend to base a lot of our technologies on the fact that a street light tends to have a networked computer to control it these days, and 30 feet up in the air is a rather useful piece of real estate for watching what's going on in the environment and making observations and spotting things that we need to track. And we'll go. And we built a set of solutions around this kind of technology. I don't want to spend too much time on it, but as you can see, it's a fairly useful technology. We can use it for surveillance, for traffic management, for parking, for pedestrian tracking. And it's all based upon computer vision. There are no human beings tracking these objects, these cars and people. We're doing this, and we're doing it at the edge. We're doing it actually in the camera. And we're just sending back these very little messages saying, there's a car here, there's a person here. Nothing, no person identifiable information. And if you look at this, if you play this one, we actually can track objects, people, cars, bicycles, and so forth, and we can actually observe what they're doing and categorize their behaviors, not just categorize the objects, but categorize interesting behaviors. And when you think about, for example, the behavior of a large crowd of people at say, a presidential inauguration, there are certain things which the law enforcement understands very well. There are certain patterns of behavior which are normal and predictable, and some which they need to pay attention to. We can actually detect that kind of pattern of behavior automatically. This next slide. And we can also integrate with regular computer video systems. We all have CCTV cameras in all our cities. We know how that stuff works. This is not that. I'll just go through that one. The point about this, though, is that we've built a set of technology solutions for applications like parking, traffic, pedestrian safety, in support of Vision Zero, which many of you will be familiar with, trying to reduce pedestrian deaths to zero. And what we've realized is that the classification techniques, the pattern management techniques, the ways of building a worldview and then detecting things that are out of sync or unexpected, we can apply those to public safety in situations. And here's another video, another simple video, if you can play that. Oops, sorry, I've got a, there's something very strange going on with in that computer there. And here this is again in the shopping mall, or actually the concourse tour to the same station we looked at earlier. And somebody's just walking through there, and pick up that stuff, and nobody would pay any attention to that person. He just picked up his bag, he was just straightening stuff, and he walks off. And we know that box shouldn't be there. We know that there's a pedestrian walked through the field. We track pedestrians, we recognize those. But we know that when that pedestrian moved through the field, it changed the worldview, and that's something which is worth drawing attention to. Now, the next step is, okay, how do we draw the attention of that? How do we integrate that into a 911 system? There's a lot of techniques which we're already applying for that. And again, these things come from other domains that we've been working in. We've been looking at parking systems, fairly mundane. We look at parking systems where when people are parking, they might obstruct a light rail system. We're doing this in Kansas City today. And what we do is we draw the attention of the police to the fact that somebody's parked obstructing the light rail. It shows up to the 911 operator just like a regular 911 call. They built a little application, so they don't have to learn a new way of doing these things. So all I'm trying to show here is that there's some interesting techniques, and we'll go to the next slide. Oh, the geeks. This is really cool. I mean, this is very cool stuff. We're doing some very interesting techniques on the edge. We have effectively a supercomputer built into the camera. And again, this would have seemed science fiction just a couple of years ago, and we're doing that today. And I can show you some demos over in the booth afterwards. These are technologies that we've developed in our labs. We haven't productized them yet. No, all the standard disclaimers apply. But when you think about the future of 911, the future of public safety, it's going to depend upon dedicated people, dedicated citizens, dedicated first responders, but also it's going to depend upon the technology that we can bring to bear to automate a lot of that processing. On that note, questions? It was all that obvious, was it? It's also, you've seen so many science fiction films that it all just seems, of course you can do that, right? Anyway, yes.
How do you see that capability, sensors, video, and so on, integrating into the NG911 process?
So the first thing is that if listening to the people talking about 911 challenges that they had over the years, a lot of these problems we solve very accurately. For example, we can when we observe an event happening, we can take that down to an accuracy of a few inches, because we got very, very high accuracy, a very high video resolution in our in our systems, and we can pinpoint that with amazing accuracy. So the challenges are not so much, how accurate are they? How can we make how can we, how accurate is our recognition and so forth? The challenge is going to be, how do we take this kind of information and transform it into a way which integrates smoothly into the existing system? Because we can't ask people to rip out their existing user interfaces and start over. And that's what they did in Kansas City, and that's what we're working on within our smart city platform, is a framework where people can put together applications which take new data from new sources, transform them into data which comes in a convenient and familiar form, and present it to the user in a way that they've already been trained in how to work with it. So that's the main integration challenge here. What I demonstrated was the recognition which has been done at the edge in the camera. We don't, that's a little more expensive than doing it back in the cloud. On the other hand, it's much more timely. You get much higher accuracy. And so we're going to have to, as the technologies evolve, we're going to have, some of these techniques applied at the edge, on the street lights, in the cameras. Some of those techniques will be applied back in the cloud to historic data. And the point really is that there's a very wide range of machine vision techniques, AI techniques, pattern recognition techniques, which we can bring to bear on this whole space. Other thoughts? Okay, thank you.
Appreciate it.